give you a sense of what we're doing and how we're incorporating the videos, but also the idea that it's sort of hard to look directly at this kind of site and tell what the instruction is about. So I'm going to move to this idea that this sharing of what we're doing involves developing a different system of representation that can communicate the structure of an intervention. Again, I think I'll just do the fast way, then I'll show you how to log on later. All right. This is, and how many of you have used Moodle? You said that you are familiar with it, so this looks really familiar to about half of you here. So this is what the course looks like, and because I'm the instructor, this isn't quite this messy for the students. I've got a lot of stuff up here that just the instructor gets. I've gone into the student role, but nevertheless it still provides me with some junk that the students don't necessarily see. So I'd just like to give you an overview of the course. I actually provide the students with an outline of topics and schedule, and that is not something that the Moodle developers particularly like, because they say I have too much there up front. But I like to give them this outline because then I don't get called, what's next? I want to go on to the next thing. So this gives them enough information so they can stay on pace. So our first unit here, Thinking, Mind, and Culture, a major goal of that unit is really to create community online, to help people understand what is good argument, and this is something that's expected of them. In fact, we have a great deal of research showing that many adults and many, many college students really don't know what good argument is. A lot of people in all walks of life cannot develop an evidence-based argument and cannot recognize one. And so one of our first challenges, because this is expected of students throughout the course, is actually to have them learn how to analyze and understand and make good arguments that cite evidence and have reasons. So we study argumentation. We also study statistical thinking in the sense that this is a model for thinking as well, that we've incorporated into our culture based on scientific research. So using hypothesis testing as a way of thinking, not in a formal way, but as a way to structure informal thinking, is another topic we take up. And we have some interesting problems that are offered in the study, Adventures in Argument. And I always try and tie this particular course to what's happening right now in the world. And so we look at a lot of videos of things like political debates. So during the healthcare debates, there was a lot of looking at the healthcare debates. And this time they looked at the President's State of the Union address and analyzed his arguments and analyzed the counter-arguments and so forth. And it was very engaging for them. The unit we're going to look at today is actually Unit 2, The Amazing Learning Brain, Part 1, Children's Thinking. And they start out, I have a wonderful teacher-friendly book by Blakemore and Firth, Brain-Based Education. We start out with some very basics about what is brain science, what's its relationship to cognitive science and neuroscience. Then they move into early brain development in language and math, and this is a unit that they are on now, and I'd like to show it to you because it does make use of some of the videos. Our required face-to-face middle of the semester class is coming up on March 2nd, and this will be followed by another unit on understanding children's thinking, in which they're going to be looking at the videos and analyzing the videos from Video Mosaic in terms of concepts in a problem-solving chapter that they have to read. And then we talk about constructivist education and teaching and the debates surrounding that. So that's this particular unit that's happening now, and I'd like to show you this. So to get to those units, the students scroll down, and I've actually closed everything. So this unit actually ended yesterday, but it's still highlighted because I'd like to show it to you in open. So I used a lot of videos. And to give you an example of the kinds of goals and the kinds of activities we do and how video is used. In this particular assignment, they've been asked to take a look at a curriculum called Your Baby Can. It's a popular curriculum. Actually, you see a lot of these materials on PBS, and there may be premiums given if you contribute, and people automatically assume if they see it on PBS, it must be great. So PBS does a lot of work with a program called Brain Gym, and people say, oh, that must be really good, it's on PBS. Well, we asked these guys to take a look at this brain science, and now evaluate these curriculum materials and tell us what you think. And so what they often discover is it's kind of pseudoscience, but just to give you an idea, they're evaluating the Your Baby Can, and I asked them in this, now you're going to see right away, this isn't really from Video Mosaic quite yet, but I asked them, all right, I have a grandson. Am I going to buy these materials for my grandson? And they have to go to the website and study these materials. So this is their discussion task. And these are, I will put all the groups together. So there's been a lot of discussion going on here, very engaged discussion. And they are still sort of, the last comments are being made today, although they should have finished yesterday. And the video they looked at is kind of fun. Funky thing about this Moodle, not all is perfect in Moodle. It doesn't really sort of go back and forth between assignments. But I just have to show you this. I can't avoid it. And I'm Grandma.
Yeah, this is your Grandma. Can you count to 10 for Grandma?
1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Yeah.
So this is not entirely frivolous. The Video Mosaic collection does not have preschool videos in it. And I happen to have this that they just sent me, and the parents gave me permission. So we are actually studying children's development of counting and awareness of number. So it's a pretty reasonable thing to start with this video and get them to think about it. But now I would like to show you the use we are making of the video collection. The next unit, early brain development in language and math. Goals to see and appreciate new possibilities and current limitations of brain research as a tool for observing and understanding children's thinking. 2, to foster an attitude of critical open-mindedness, enabling you to draw on brain science to support your thinking as an educator while avoiding common misconceptions that often result from overreaching interpretations of brain research. Famous misconceptions, that you only use a small part of your brain, that you know, your brain cells start dying off when you're 20, and so forth and so on. To encourage curiosity and deeper observations and thinking about the interconnectedness of language and mathematics in child development. One of the findings, some of the fascinating findings of brain research involve looking at what parts of the brain work together. And there is a not entirely well understood, but very interesting connection between the development of language skills and the development of mathematical thinking, and in particular even the ability to calculate depends largely on language. So they're exploring this, and so I go to the video collection and say, are there some good videos that actually help me illustrate this point? And so the forum that the students participate in asks them to view this video and talk about what they see regarding this interconnection between language development and mathematics development, and how is that related to the brain science that they've just read. So I'm trying to get them to not be shy in thinking about the possible implications of this brain research while at the same time realizing they can't really draw, they can't overblow what connections are being made. But yeah, these are tools for helping teachers think about this. So now, this is actually not in the video mosaic. This will be one of the videos it goes in next.
If you have 1/2, and if you take the 1/2, which would be the dark green, you have the 1/2, and then these are the thirds.